Something I want to touch on real briefly. So you have multiple load cells, so this is important. And we'll go over this again when we swap the load cells from one to the other. So essentially, this load cell communicates to this frame via something called a cal cable. And the cal cable is this little guy right here. And inside that cal cable, as the name implies, contains all the calibration data with your load cell. So essentially there's little strain gauges, resistors in this load cell. As the load cell deforms, the resistance changes. When we calibrate the load cell, we associate that resistance change with a certain force. So all that data is contained in this cal cable. Whenever you do a restart of the frame, whenever you turn the frame off and turn it back on, you need to rewrite this data. Essentially, in the frame, it's volatile data, meaning when you turn it off and on, it gets erased. So you need to copy it back. Something that's very important to consider with this cal cable is that you cannot disconnect it or reconnect it when the frame is powered on. And the main point behind that is that, like I said, all the data is connected in that cable. When you plug it in or unplug it, there's a tendency for a small arc to happen between the connector and the plug itself. So this is similar to how if you plug in with your car stereo, other type of stereo, plug in your auxiliary connector, your 1/8 inch, you're going to hear kind of like a little pop. So what that pop is actually a little electronic arc, or electric arc going from the socket to the connector. The same thing would happen with this as well, except that arc is enough to clear the data or to damage the data. So that's something that we kind of like to reinforce, is that to not have the frame on when you're changing the load cell cal cables. If the data were to be erased, it would require a Shimadzu representative to come out and recalibrate the load cell. Alright, those are kind of the main features of the frame itself. What we're going to do right now, like I said, go from the tensile setup right now, which is already hooked up, go to a compression setup, and then swap in the smaller load cell. Something to note about this that's different than some of the other frames is that how you connect and disconnect things, there's a set procedure in doing it because of the masses of the components themselves. In a smaller frame, you can kind of just toss your jigs up there, tighten up, it's good to go. Whereas here, you kind of have to use the frame to work with you. So right now what I'm going to do is lower the one grip down to the other so that they slightly touch. No limit switch works. So get them close together. I mean, don't necessarily have them touch. So right now, again, I kind of skipped forward, but the different components in this tensile setup, and we'll go through it more when we do the tensile setup for the smaller capacity load cell. Starting from the bottom to the top, you have your lower joint, your lower grip, your upper joint that threads into the load cell. And up top here we have the load cell bolt. So I'm going to have to run over here for just a second to get a rotation rod to loosen the load cell bolt. So as I loosen this grip is going to kind of drop down on the other grip. Raise the crosshead. And I actually skipped a step. We actually want to take the grips off first before we take off this upper joint. And again, like I said, With smaller capacity frames, it doesn't really matter the order in which you take things off, but with the higher capacity, you do kind of have to think ahead as to what component you need to take off first, which is heaviest, and how you can have the frame work for yourself. So attaching the grips to the top and the bottom are these lock collars, and these lock collars are disengaged by these spanner wrenches, and essentially this collar is threaded on here, and to fix the grip to the joint, whether it's the upper or lower joint, you move the collar towards the joint. So to disengage, I'm going to move the collar down. We can now remove this clevis pin.
There was a load on the pin, that's why it's not touching the drum.
So let's try to. I just looked it up and you can have it out.
Okay.
All right.
Does the jaw need to come out first before undoing that tough nut?
Thanks.
we know the weight on those jaws?
40 kilograms.
40 kg.
40 kilograms.
So we could essentially zero and then unload 40 kilograms, so it would be no force on that clevis pin.
That would be a good way to do it. All right. So now we'll take up the top joint. The diameters of the upper joint and lower joint are the same, so that makes it easy for it to set down on the lower joint for disassembly, but also it helps with alignment for the assembly of everything. That is accurate enough to get maybe not change the strain of the thread. Right. Even the clip-on or whatever the other expensive. Or you have the choice. Still feel it. Oh, okay. She was calculating it.
Same size as this one? So we're getting downstairs.
We use the crosshead. Now we can remove the lower joint. And after we remove the lower joint, the lower compression plate will fit right on top of the table. So helping to center the lower joint is this little centering pin that can be removed or replaced within the table. we'll take this little mat off. This mat is mainly used for tensile testing, and it kind of covers up some of the accessory bolt holes so that when you are testing, none of the sample remnant kind of migrates down into the table.